Alright, we're going to be looking at 3 formulas today involving circles. So we're going to be looking a little more closely at how to calculate specific parts of a circle. So the first thing we're going to look at is what we call sector area. So let's define what sector area is first. So go ahead and put a center of a circle. Let's call this circle, circle B. And what we're going to do is we're going to basically cut a piece out of this circle, so kind of like a pie piece. So we're going to create this radius B to A, and this radius B to C. And then what I just created was I just created a sector. So the sector is basically this red shaded region. So this is what we call our sector area. So it's going to be basically the area of one piece of this giant circle. So like one piece of the pie, if you will. Okay? Now, the important pieces for this circle, for us to calculate it, are 2 things. So we want to know the length of the radius and also the measure of the arc. And remember, that arc measurement could also be the central angle, so they're the same thing. All right? And sector area is one simple formula, pi r squared, which is the area of a circle, right, times m over 360. And that's going to tell us what portion of that 360-degree circle are we actually calculating. So again, it's the area of the circle, pi r squared, and then times just the piece we want, so m over 360. Okay? So take a look at example 1. We want to find the area of sector HGJ. So when we're talking about sector HGJ, we want to go ahead and look at the sector defined by that central angle. So this shaded region is a sector we're looking for. Okay? So remember, go ahead and write your formula. So area of sector HGJ is going to be pi times radius squared times m over 360. Right? So here our radius is given to us. Our central angle measure, which is also the arc measure, is 30. Super simple, plug it all in, and let's see what we get. So this is going to be pi times 5 squared times 30 over 360. Now I want you to leave your answer in terms of pi, so you want to make sure you don't round your fraction. So you want to be careful with that. So we're going to get 25 pi times 30 over 360, which I could actually reduce down to 1/12. So then my final answer is going to be 25 over 12 pi. Again, this is area, so it's going to be square units. All right. So again, leave your answer in terms of pi as an exact answer. Reduce that fraction. Okay? And that is sector area. So let's take a look at now what we call segment area. So again, let's define what a segment is. So a segment is going to be a specific piece of the sector. So once again, let's go ahead and put in a center of our circle. Let's call the circle A. And then we can have 2 points on the circumference. So to create an arc, we can call that BC. And to create the sector, what we do is we're going to draw a chord from B to C. And this tiny little sliver here, that is what we call the segment. So that is the piece of the sector that we're going to be finding the area of. And to find the area of the segment, it's related to the sector area. So if you just imagine this, how do we create a segment? Well, think about it. You take your circle, right? And we have the sector BAC. So if this is that whole sector, what shape am I taking away to just create BC? Well, think about it. I need to take away the triangle. So to find the segment area, we had to basically take the sector area, that's a sector, minus the area of the triangle, so triangle area. And that's going to be basically what we're doing to find segment area. So the tricky thing is actually to find the triangle area. So let's take a look at example 2 and work this out. So we want to find the area of segment LMN. So you want to make sure you see that vocabulary. We're looking for segment versus sector. So we're still referring to it based on the central angle LMN. But since that keyword here is segment, we know we just want this tiny little sliver. Okay? 2 pieces. Find the area of the sector, then find the area of the triangle. So we can do this separately. So go ahead and use our sector area formula. And go ahead and find that area in terms of pi for me. Check and see if you got that 27 pi. That's what we're looking for. And that 27 pi is again in terms of pi, obviously. So you didn't want to multiply by 3.14 or touch your pi button at all. So now let's think about how would you find the area of our triangle. So this is a little bit trickier. So let's go ahead and draw your triangle out. And we've got this lovely triangle LMN. And we know the area formula is 1/2 base times height. And the question was, what is B and what is H? Because I need that to figure out my area. So let's label what we do know. We know our radii, ML and MN, are both 9. So we're creating this lovely isosceles triangle, right? And then remember, your arc measure, this 120, is also the measure of the central angle. So that's probably pretty important. And wait, when did we talk about isosceles triangles and central angles, guys? Doesn't this make you think about your area of a regular polygon? So what do you think I'm going to have to do? I'm going to split this thing in half. And I know this is 9, which then makes the central angle 60. And then I cut it down this middle, so I get that 90-degree angle. So then I'm creating height. And this is going to be 1/2 of my base, right? Which we can call x for now because we know the whole base is 2x. Now think about it. How do I find x? How do I find h? What do you think we're going to use? Well, we're going to be using SOHCAHTOA. So let me just move this up to give me some more space. So think about it. To find h, what are we using? Sine, cosine, or tangent? Well, from h, 9 is the, or excuse me, from 60, 9 is the hypotenuse, and h is my adjacent. So what uses adjacent and hypotenuse? Well, remember, that is going to be cosine. So cosine of 60 is equal to h over 9. So you can go ahead and cross multiply to solve, and I'm going to get h equals 9 times cosine 60. Okay? I'm just going to leave this the way it is. Ooh, sorry about that. And then I'll do it all on my calculator later. But of course, you can round earlier, but I'm going to wait and do all this together when I calculate area. So now tell me, how do you think you're going to find x? Well, x is from the 60. This is the opposite. And again, we know 9 is hypotenuse. So what uses opposite on hypotenuse? Well, that's going to be sine. So sine of 60 is equal to the opposite over the hypotenuse. Again, cross multiply to solve. And we're going to, ooh, I'm touching everything all over the place. So let's go ahead and cross multiply and solve. And we're going to get x equals 9 times sine 60. And since my base length is 2x, that's going to be 2 times 9 sine 60. So this is going to be 18 sine 60. Now I can find my triangle area. So area is going to be 1/2 of 18 sine 60 times height, which is 9 cosine 60. And then I'm just going to throw all that in my calculator and round it. So we're going to get approximately, and that actually worked out really nicely because that gives me an exact answer of 20.25. Right? So now we've got our sector area, we've got our triangle area, put it all together. So my segment area, I'm going to do this over here, is going to be sector area minus triangle area. And if I'm leaving this in terms of pi, that's really as much as we can do. But let's actually just round this. So let's round to the nearest 10th. So again, if I want to leave this in terms of pi, that's as much as you can do, because there's no pi by the 20.25. But if I want to round this to the nearest 10th, then I'm going to go ahead and get 49.8. And since it's, again, area, it's square inches. All right, so you want to just make sure you're double checking how to find the base and the height of that triangle. So that's what makes it a little bit trickier, but it's SOHCAHTOA, which we know how to do, okay? Last thing, arc length. So what is arc length? Well, we know what an arc is, right? So if we go ahead and go back to our circle, draw in your center, we can call the circle, let's call it X, and I can create an arc anywhere I want. So I can go Y and Z, okay? Now arc length is exactly what it sounds like. We want to find the length of Y to Z. So what is the distance from Y to Z? This part of the circumference is what we call arc length. So again, it's part of the circumference. So what do you think is going to be part of our formula for arc length? The circumference. And again, it's just one piece of the circumference, so it's going to look very similar to sector area, so just be very careful, okay? So arc length, oops, I can spell Length. That's going to equal, again, circumference, which is 2 pi r, times the piece of the circle. So that's still going to be m over 360. So once again, we do need the degree, and we still do need the length of the radius. Okay? So let's go ahead and do one last problem, and we are done. So we want to find the length of arc BC. So you want to make sure you see the difference between length and measure. Measure means the angle. Length means the actual distance. Okay? So arc length, again, the formula, that length is going to be 2 pi r times m over 360. Now take a look at what we have, right? Radius is 4, m is 112, and again, you can either be given the arc measure or the central angle. They'll give you the same thing. Just plug it in, right? 2 pi times 4 times 112 over 360. We're going to round this in the nearest hundredth this time, so go ahead and just work this whole thing out. And there we go. So I did it both in terms of pi, so you guys can see what it would look like in terms of pi, but also rounded to the nearest hundredth. And because we're talking about length, it's not square inches, it's just plain old inches. Okay? 3 formulas, or 3 ways to really solve today. And we'll be practicing this in class. Make sure you do go back and review how to find the area of that triangle, though. All right? Come back with questions. Thanks for listening.